Hey guys, welcome back. Problem of the week this week. This week I wanted to have a look at a chain differentiation problem. So differentiation problem using the chain rule, but I've picked one specifically out of our methods your practice question ebook, and I've picked it specifically because it's 4 layers. So it's 4 levels of chain rule, and I want to work our way through it so that we can hopefully make the most of a really challenging problem like this. So I'm going to go down to our calculus tools, find chain rule, which is on page 50. So I'm going to jump to page 50, and I'm going to go all the way down to the bottom to this last little problem right here. It is a fun, quirky, intense problem. So I'm going to very quickly copy and paste that problem into a OneNote doc, and then we're going to work our way through how to tackle this problem. And I'm going to do it live on screen. Well, not live, this is now a recorded video, but you'll be able to see exactly what's going on, and we can work our way from there. So let's paste this in. Now, what's interesting about this is we're trying to differentiate a function that is layered, really well layered into a bunch of different pieces. So we've got our problem here. We've got find the derivative of cos of the exponential of sine of 5x cubed. Now, if that doesn't scare the pants off you, I don't know if anything will, which is great. We're going to work our way through it. Now, the chain rule in particular is great because it lets us delve into how to tackle problems step by step by step by step, and it allows us to build out problems piece by piece. Now, to actually break this problem apart, I'm going to take this one step at a time, and I'm going to start from the outside and work my way in. So the first thing I'm going to do is I'm going to rewrite this, and I'm going to rewrite this as the derivative of cos of u, where u is equal to e of sine of 5x cubed. Now, in theory, to use the chain rule, what I would have to do is I would have to do, let's say dy dx is equal to dy du multiplied by du dx. This is a classic definition of the chain rule. Now, here's the problem. dy du is relatively straightforward because we have this function in terms of u, and we can differentiate it relatively easily. The derivative of cos is a negative sign, so we can say that dy du is equal to negative sine u. Now, the problem is this du dx because we have to differentiate u, but we know that u is this intense, complicated term that realistically we need to use the chain rule to differentiate. So what we're going to do is we're going to break it apart yet again. I'm going to use a different color to try and keep us a little bit more organized. You can do this with boxes or just separate sections of the page, whatever you want to do. But we're going to use the chain rule again, and we're going to say that u this time is equal to e of, let's say, w, where w is going to be our inside piece. So we're slowly breaking this down into smaller and smaller pieces, but notice how I'm working from the outside in to try and break it into pieces. So I'm going to say that w is equal to that, the power, which is sine of, 5x cubed. And this way, we've managed to break it down again, so that when we do du dx, which is the piece that we actually need for here, we're going to use the chain rule and say that that's equal to du dw times dw dx. So you see how I'm just constantly separating them into smaller and smaller pieces. Now this time, du dw is relatively easy because the derivative of e to the power of w when it's in terms of w is just e to the power of w. All right, that's the derivative of our original u. Now, the second bit, dw dx, that's where we run into trouble because then we have to differentiate this monster nightmare. Now, some of you may be very comfortable with this, and if you are, you're more than welcome to skip to the part where you know what the derivative of w is. But this is an opportunity to practice the chain rule yet again. So what we're going to do is I'm going to branch out to yet another color, and I'm going to move over to the third side, and I'm going to take this piece and I'm going to try and differentiate it. So I'm going to say that w, let's try and pick a different color. W is equal to sine of, let's say, I don't know, V. Why not? Okay, where V is equal to 5x cubed. Now, finally, we're in a position where we can actually differentiate both of these pieces. So that's what we're going to do. We're going to say that dw dx, which is the piece that we originally wanted, is equal to dw dv times dv dx. And we can actually work out both of these pieces. So what we're going to do now is we're going to basically track our way back, and we're going to be able to fill in these blank pieces that we have left open for ourselves. So that we can actually finalize this question. Well, that's actually supposed to be the green piece, but let's work our way through this first. So dw dv, the derivative of sine of v, is going to be cosine of v multiplied by dv dx, which is going to be the derivative of v, which we can actually work out now because we know how to differentiate 5x cubed. So we're going to say that that's 15x squared. Now we can start to track our way back up. Now we're going to try and put everything in terms of x as we go. So right now I'm going to write this instead as cos of v, but I know that v is 5x cubed. And then I'm going to multiply it by 15x squared. And before I sub it back in, I'm just going to clean it up a little, just to make it a little bit tidier before I start to push it back towards here. So I'm just going to not do anything really fancy, just try and neaten it up a little. But then once I have that organized, I can slot that back in, and that is our dw dx. So now I can go 15x squared cos 5x cubed. And now that I've got that missing piece, I can start to finish off this second level. Now the second level, I'm going to do the exact same thing. I'm just going to tidy it up a little bit more. So I'm first going to write this out again as EW, except we know that W is sine 5x3. So I'm going to write E of, let me just get a better color for that. E of W, so E of sine 5x3 multiplied by 15x squared cos 5x3. And before I go ahead and sub it back into this piece so we can finish off this problem, I'm going to tidy it up yet again. So I'm going to rewrite it as 15x squared cos 5x3 E sine 5x3. And then finally, now that I've got all of my pieces lined up, I can go back and actually put this back into the place and make sure that everything fits together. So now I can fill in this blank space, which is the derivative of u in terms of x, which is what we were looking for all along. So you can see what I've done is I've basically broken it down piece by piece. I've tried to keep it as organized as I can and really clearly labeled. I find that really clearly labeling something when you've got so many steps going on actually helps you to keep it organized. I also love using color to try and segment the different sections. So you can see that I started with the blue section, and then the green section was like a sub-problem, and then the red section was a sub-problem in the green section. So you can see how I'm like piecing this together. Finally, we're at the final stage, and so we can actually put this together. And now we're working on the blue section. We finished the red section, then we finished the green section. Now we're working on the blue section, and we can actually rewrite this. So we can finally say that dy dx is equal to negative sine of u, but we know what u is. So we're going to say negative sine of u, which is E of w. So negative sine of E of, well, w, which is sine 5x3. I'm going to close that bracket, and then I'm going to say multiplied by 15x squared cos 5x cubed E sine 5x cubed. Boom. Now the only thing left to do is tidy this up a little, so I'm just going to rewrite it. I'm going to put the number right at the start along with the negative sign, x squared, and then we've got cos 5x cubed. I like put sine and cos next to each other if they're going to have to be in the same line. E sine 5x cubed. Boom, boom, and then the E. Oh, I don't even need that last bracket. And we get everything put together. Now, there's a lot going on there, but what we really did is we just pieced it together, piece by piece by piece by piece. Each time we started from the outside and used the largest inside piece possible to break off into our second letter. Then what we did is we basically rinse and repeat this process again and again and again until we get through to a level that we can actually work with, which was the end of that red level. We finally got down to a piece that we could actually differentiate without using any chain rule. So we did it, and then slowly but surely worked our way back up the ladder. Now, this is a really classic example of the problem-solving strategies that I was talking about in my email last week. So if you're a little bit unfamiliar, maybe go check that out. If you need to watch this video again, watch it again. I'd love to know what you think, and if you have any suggestions or if you have any questions about it, you can pop them in the comments or send me an email, and I'd be more than happy to help you out. Anyway, I love that you guys stuck around for this. If you're interested in grabbing the practice question ebook that I mentioned, flick me an email and let me know, and I will show you how you're able to get a hold of it. Otherwise, I look forward to making yet another one of these videos, and I'll catch up with you next week when we do this whole thing again. If in the meantime you have questions that you think would be great for us to tackle, I would love to take student submissions to tackle these questions as well, rather than coming up with questions ourselves. So if you have any questions, you can email me. My email is christian@simplymaths, that's simplysmaths.com.au. I'll put it on the screen. And you can send me an email, let me know what questions you'd like me to tackle, and we can do them for a video next week. Anyway, thanks very much for watching. Hope you guys have a great time, and I will see you guys next week. Bye!